refraction of light. Let us suppose this A, B, C, D, E, F, G, H, A, B, C, D, E, F, G, H is a glass slab. And a light ray M, O MO is incident on the upper surface, that means this surface of this glass slab. This slab is transparent. Glass is a transparent material. When light is incident on one of its surfaces, it allows to pass or to transmit the light through the medium. So glass slab is a transparent medium. A part of light, that is ON, passes through the glass, and another part, OP, is reflected back to the same medium. This ray, OP, is known as reflected ray. And this ray, ON, is known as refracted. And the bending, now notice this angle is theta. In accordance with the law of reflection, this angle also theta. But when the light enters from one medium to another medium, suppose this medium is medium number 1 and this medium is medium number 2. So when light enters from one medium to another medium, it bends. It bends either towards the normal or away from the normal. In this case, this particular case, that means if this medium is air medium and this is glass medium, then light ray will bend towards the normal, and this angle is called angle of refraction, R. So theta is equal to incident angle or angle of incidence, angle of incidence, and R is equal to, sometimes it is termed as I also, angle of refraction. In the book NCERT, in the NCERT book, this section has been discussed page number 317, and there this angle is taken to be I. There are two rules or laws related to refraction of light. Laws are given in the NCERT book also, page number 317. Number 1, the incident ray, the refracted ray, and the normal to the interface. This is the normal, x prime. This is the normal. normal to the interface, at the point of incidence, all lie in the same plane. Incident ray, normal, and the refracted ray. Three lines lie in the same plane. Number one rule. And number two, the ratio of sine of angle of incidence. The ratio of sine of angle of incidence, sine I, and the sine of angle of refraction. This is the ratio. The ratio of the sine of the angle of incidence to the sine of angle of refraction is constant. It is a constant quantity. And this constant quantity is a constant quantity, and by convention it is written as n to 1, where n to 1 is known as n to 1 it is known as refractive index of the second medium. With respect to the first medium. With respect to the first medium. So in brief, this is all about the laws of refraction of light. Now we have to study some implication of Ri or refractive index. Sometimes this ratio is written as mu. It's a Greek letter. Mu or mu 2 1 or simply mu. So that is the refractive index of the second medium, that means glass medium, with respect to air medium. This is an index, and this index has much implication that determines the optical property of the medium. That means the extent of bending. Suppose this is the suppose okay, this is the separating line between two media. The upper media is there, number one, and number two, the lower medium is glass or water. It may be glass or it may be water. Now, when light is incident at the interface of two media, this is the normal at the point of incidence. This is the ray, incident ray. The light bends like this, in this manner. That means R is smaller. This angle is R, angle of refraction. This angle of incidence. R is smaller than I. Okay. Sometimes R can be greater than I. So we are drawing another figure. This is this line separates two media, and this line is the normal. Now this green line is the incident ray, and another green line is the refracted ray. So in this case, this is I. In geometrical optics, you have to indicate the sign of the rays. So this is I and this is R. So watch this and the distinction between the two medium. Suppose this medium is termed as 3 and this is 4. Particularly in this case, I is less than R, just opposite, or R is greater than I. When light is incident from rarer medium to denser medium, from rarer medium to denser medium, this type of refraction happens. That means if this is air and this is water, somehow if it is altered, that means this is denser glass and this is air, rarer medium, from glass to air, just opposite happens. That means I is less and R is greater. So this is the particular distinction between two types of refractions, whether the refraction is occurring from denser medium to rarer medium or denser medium to rarer medium and rarer medium to denser medium. Now, in the book of NCERT, very good information regarding the optical density and physical density has been given there. Optical density should not be confused with mass density. Optical density upon which the denser or rarer term is used. Optical density. Actually, this optical density determines whether the medium is denser or rarer. This optical density should not be confused with the physical density. That is mass per unit volume. Mass per unit volume determines the physical density. But optical density is totally different thing. It determines the optical nature of the medium. Now, we have termed N21 as refractive index of medium to with respect to medium 1. Similarly, N12 can be defined as refractive index of medium 1, just opposite, with respect to medium 2. And it can be proved n12 is equal to 1 by n21, etc. That means the reciprocal is also 2. Now there are some valuable informations regarding optical density, regarding refractive index, etc. You have to follow the matter. I am taking the third page. Actually, refractive index in some books Ri is equal to n or n21 or n12, and in some books it has been given as Ri is equal to mu. Ri is equal to mu. So we must remember n or mu. These two notations are used in the same sense, and n is equal to Ri or mu is equal to Ri everywhere. Now n GW, suppose we have written n GW. That means n of G by n of W. Just opposite sign or opposite notations are used here. Don't be confused. Follow only one book, but somehow the NCERT book is not sufficient for studying these particular topics. That means refraction. You have to go through several books. There is another definition for Ri, mu or I, mu or n of a absolute value. Absolute value of mu or n. This is relative value. When one quantity, the value of one quantity is determined with respect to another quantity, that is relative value. But absolute value of mu. So we are writing here a line, absolute value of Ri, refractive index of a medium. So absolute, suppose the absolute value of n of class Ri, Ri of glass is equal to n, G. Then Ng is defined as speed of light in vacuum speed of light in vacuum divided by speed of light in glass medium. And sometimes this is said like this, C by V, G suffix. C is absolute value. So there is another formula Ng is equal to C by Vg, where Ng, G is a suffix here. Ng is equal to absolute value of refractive index of glass. Vg is equal to speed of light in glass, and C is equal to speed of light in vacuum. So this formula will be used whenever it is necessary to solve numerical problems. Remember this, your NCERT book is not sufficient to clear the required idea. You have to study another books, and I will give you the reference number of reference books in the forthcoming videos. Now another formula, that is Snell's law in general form. We will take another page. Let us suppose this is the separating line between two media, and this is the incident light. This is the normal on the surface, and this is the refracted ray. Okay, this is incident ray, this is refracted ray, this is angle of incidence theta 1, this is angle of refraction theta 2. The Ri of this medium is equal to N1, and Ri of this medium is equal to N2. Okay. Ri means the absolute Ri, and Ri means N2 is absolute Ri of this medium. This is medium number 1, and this is medium number 2. Now, according to Snell's generalized rule, N1 sin theta 1 is equal to N2 sin theta 2. If there is another medium like this, so this is second medium, and there is another medium like this, third medium. And at the interface of the third medium, at this point, this will be the normal. And as the light changes from medium to another medium, it will further bend either towards the normal or away from the normal. Suppose this point bends the light in this manner. This manner. Then this is equal to the Ri of this third medium is equal to N3, and suppose this angle is equal to theta 3. Then it will be N3 sin theta 3. So N1 sin theta 1 is equal to N2 sin theta 2 is equal to N3 sin theta t is equal to Ni, generalized concept, ith medium sin theta I is equal to constant. This is known as Snell's and Snell's generalized law. This law is also important for further discussion. We have to discuss a lot regarding refraction of light. So this is all about the fundamental concepts of refraction. Thank you for watching.